Imagine if you could teach a computer to understand that king is to queen as man is to woman, or that Paris and France have a similar relationship to Tokyo and Japan. This seems impossible. How can a machine understand meaning and relationships between words? The answer lies in one of the most fundamental concepts in mathematics, vectors. Today, we'll discover why vectors are the secret language that allows artificial intelligence to understand human language and think in ways that seemed like science fiction just decades ago. Let's start with the absolute basics. What exactly is a vector? Think of it as an arrow in space. If you want to give someone directions, you don't just say go 5 miles, you say go 5 miles northeast. That's a vector. It has both magnitude, how far, and direction, which way. In 2 dimensions, we write this as coordinates like 3, 4. But here's where it gets fascinating. Vectors can exist in any number of dimensions. While we can only visualize up to 3 dimensions, mathematics allows us to work with thousands or even millions of dimensions. Why would we ever need vectors with hundreds or thousands of dimensions? Think about describing a person. You might use height, weight, age, personality traits, interests, skills, dozens of different qualities. Each quality is like one dimension. To fully capture the complexity of human language, we need vectors with hundreds of dimensions. Each dimension represents a different aspect of meaning. One dimension might capture royalty, another gender, another country relationships. This is how we can mathematically represent the rich, complex meaning. Why are computers so good at working with high-dimensional vectors? Because at their core, computers excel at mathematics, and vectors are pure mathematics. When we represent the word king as a vector like 0.2, 0.8, 0.1, 0.9, the computer can perform mathematical operations. It can measure how similar 2 words are by calculating the angle between their vectors. This is called cosine similarity. Words with similar meanings will have vectors pointing in similar directions. This transforms the fuzzy concept of meaning into precise mathematical calculations that computers can process billions of times per second. Why does representing words as vectors suddenly give computers language understanding? Because vectors capture relationships through mathematics. When we train AI systems on massive amounts of text, they learn to place similar words close together in this high-dimensional space. The magic happens when mathematical relationships between vectors mirror real-world relationships between concepts. Subtract man from king and add woman, and you get a vector very close to queen. This isn't programmed, it emerges naturally from the mathematical structure. Vectors transform language from symbols computers can't understand into mathematical patterns they can manipulate with incredible precision. Let's see how large language models actually use vectors. When you type a question into ChatGPT, every word is instantly converted into a high-dimensional vector. The model then uses these vectors to understand context, find relevant information, and generate responses. It's like having a vast mathematical landscape where similar concepts cluster together. The AI navigates this landscape, finding patterns and relationships to understand what you mean and predict what comes next. Every word, every sentence, every idea becomes a point in this mathematical space that the AI can explore and manipulate. Vectors are the bridge between human language and machine understanding. They transform words from meaningless symbols into rich mathematical objects that capture relationships, context, and meaning. This breakthrough enables everything from Google Translate to ChatGPT to recommendation systems. Every time AI understands what you're asking, finds relevant search results, or generates human-like text, vectors are working behind the scenes. We've taken the infinite complexity of human language and found a way to represent it mathematically, and that changes everything.